This lesson will discuss valence electrons and their pattern within the periodic table. Let's begin with some basics. The horizontal rows of the periodic table are called periods. This is because properties of the elements periodically reoccur or repeat in predictable patterns. There are 7 periods, and each one corresponds to the number of energy levels in the atom that contain electrons. For example, hydrogen is in period 1, and its atoms only have electrons in energy level number 1. Rubidium is in period 5, so its atoms have electrons in energy levels 1 through 5. The vertical columns are called groups and are numbered 1 through 18. They're also called families because elements in the same column tend to have similar chemical and physical properties. While people in the same family have similar features due to their shared DNA, elements have similar properties due to similar electron structures. Let's examine how this works. Take a moment and write the noble gas electron configurations for beryllium, magnesium, and calcium. Pause the video while you work, then restart the video when you're ready. The noble gas electron configuration for beryllium will begin with the noble gas that ended the period before it, which will be helium. Since helium is in the S block of the first period, writing helium in brackets will account for all the electrons through 1s of our arrow diagram. Following the arrow diagram, the remaining 2 electrons will be in 2s, or the S sublevel of the second energy level. If you need a refresher on electron configurations, watch my Intro to Electron Configurations video. You'll find a link in the description below. The noble gas configuration of magnesium will begin with the noble gas that ended the period before it, which is neon. Neon's 10 electrons fill from 1s through 2p. Picking up from there, the remaining 2 electrons go into 3s, or 3s2. The noble gas configuration of calcium will begin with the noble gas that ended the period before it, or argon. Argon's 18 electrons will fill from 1s all the way through 3p. Picking up from there, the remaining 2 electrons go into 4s. From these configurations, we can see that each of these elements have 2 electrons in their outermost or valence energy level. And it's those same number of valence electrons that give the elements in a family similar properties. Remember, the valence electrons are all the electrons in the outermost energy level of the atom. These are the most important electrons since they're the ones involved in bonding. Elements with the same number of valence electrons will bond and behave similarly, resulting in similar properties, which is why elements in a vertical column are considered a family. If you were to compare the electron configurations to determine the number of valence electrons for each column, you'd notice a pattern across the periodic table. The electron configuration of all atoms in group 1 end in S1, so every element in that group has 1 valence electron. We already saw that elements in group 2 have 2 valence electrons. Due to belated filling, all the transition elements have 2 valence electrons. The boron family has 3 valence electrons, the carbon family has 4, nitrogen 5, oxygen 6, fluorine 7. The noble gases have 8 electrons in their outer shell, except for helium with an atomic number of 2, so it only has 2 electrons in total. It's important to memorize this pattern so you won't always need to write out a configuration to determine the number of valence electrons an atom has. The octet rule states, an outer shell of 8 makes the atom feel great. Say it with me. An outer shell of 8 makes the atom feel great. Atoms will gain, lose, or share electrons to get 8 electrons in their valence shell, and will form bonds to do so. Since noble gases already have 8 valence electrons, they're inert and tend not to react with other atoms.